Gregory Chaitin is an Argentine-American mathematician and computer scientist renowned for his pioneering work in algorithmic information theory 8, which he developed in the late 1960s while still a teenager. He is considered one of the founders of algorithmic complexity, alongside Andrei Kolmogorov and Ray Solomonov, focusing on the relationship between computation and information. Chaitin's key contributions include the definition of Chaitin's constant omega, a non-computable real number representing the probability that a random program will halt, and a computer-theoretic result equivalent to Gödel's incompleteness theorem. He also introduced Chaitin's algorithm for register allocation using graph coloring in compilers. Chaitin's work in 8 has indirectly influenced computational linguistics by providing a framework for understanding information complexity and randomness, which can be applied to areas like natural language processing and data compression. His interdisciplinary insights also extend to digital philosophy and metabiology, exploring computation's role in biology and consciousness. Gregory Chaitin, an Argentine-American mathematician and computer scientist, was born in Chicago in 1947. Even as a teenager, he displayed an exceptional aptitude for mathematics and computer science. He attended the Bronx High School of Science and then the City College of New York, where at the age of 15, he independently developed the theory that is now known as algorithmic information theory. Due to his groundbreaking work, his college dean excused him from classes so he could prepare his paper for publication. He received the Belden Mathematical Prize and a gold medal from the college for his work. Despite his revolutionary insights, Chaitin's only formal degree is a high school diploma. On the Length of Programs for Computing Finite Binary Sequences 1966. Introduces the concept that the algorithmic information content of a string is the length of the shortest computer program that can produce it. This idea is central to his work and can be applied to understanding the complexity of linguistic structures. A simple or compressible sentence or text would be one that can be generated by a very short program, whereas a random or unstructured one would require a program as long as the text itself. This provides a theoretical measure for the conceptual complexity of a theory or a text. Information Theoretic Limitations of Formal Systems 1974. In this highly significant paper, Chaitin connected his work on algorithmic complexity to Gödel's incompleteness theorem. He demonstrated an information theoretic version of the theorem, showing that any sufficiently powerful formal axiomatic system has a limit to the number of truths it can prove. Specifically, he showed that for any such system, there's a bound on the algorithmic complexity of the specific numbers that can be proven random within that system. This showed that randomness is a property that can exist but is beyond the reach of formal proof, a profound result that reinterpreted the nature of mathematical truth. A Theory of Program Size formally identical to Information Theory 1975. This work further develops the relationship between program size and information theory. By proposing a formal identity between the two, Chaitin provides a mathematical lens for analyzing information. This approach is not specific to human language but offers a way to measure the expressive power and conceptual complexity of ideas, which is directly relevant to how we might analyze language and communication from a computational perspective. Randomness and Mathematical Proof 1975, Scientific American. While not a technical paper, this article is highly significant for its role in bringing Chaitin's ideas to a wider audience. In a clear and accessible style, Chaitin explained his information theoretic take on incompleteness and the profound philosophical implications of his work. It introduced concepts like algorithmic randomness to a non-specialist public and generated significant discussion about the nature of mathematics and its limits. Information, Randomness and Incompleteness World Scientific 1987. This book is a compilation of Chaitin's groundbreaking papers on algorithmic information theory. It introduces the concept of program size complexity as a measure of information, a key idea that provides a mathematical framework for randomness. The work explores the relationship between this measure and fundamental concepts in mathematics, particularly highlighting the incompleteness of formal axiomatic systems, a topic previously explored by Kurt Gödel. This publication helped to establish algorithmic information theory as a significant field within computer science and mathematics. Algorithmic Information Theory, Cambridge University Press, 1987. A foundational text, Algorithmic Information Theory presents Chaitin's work in a more accessible and cohesive form. It systematically develops the theory from its basic principles, defining algorithmic randomness as the property of a string of data that cannot be compressed into a smaller computer program. The book's central thesis is that the randomness of a mathematical object is a measurable property, showing how this idea connects to classical theorems of mathematical logic, like Gödel's incompleteness theorems. Information Theoretic Incompleteness, World Scientific, 1992. In this work, Chaitin delves deeper into the philosophical and mathematical implications of his theories. Information theoretic incompleteness extends the ideas of algorithmic information theory to demonstrate a new kind of incompleteness for formal systems. Unlike Gödel's result, which shows that a specific statement is unprovable, Chaitin's work reveals that a formal system cannot prove that any given bit string is random. This implies that there are an infinite number of mathematical facts that are true for no reason and simply have to be accepted as axioms. The Limits of Mathematics, Springer Verlag, 1998. The Limits of Mathematics presents Chaitin's ideas on randomness and incompleteness in a style aimed at a broader audience, including mathematicians and philosophers. The book argues that mathematical truth is not entirely a matter of logical deduction. It suggests that just as in physics, where experiments reveal new truths, in mathematics, new facts may emerge that cannot be proven from existing axioms. The book uses the concept of the halting probability, omega, as a concrete example of a number that is mathematically well defined but unknowable. The Unknowable, Springer Verlag, 1999. As a follow-up to The Limits of Mathematics, this book further explores the concept of the unknowable in both mathematics and philosophy. Chaitin emphasizes that his work on algorithmic randomness provides a new, concrete instance of unknowability that is distinct from Gödel's findings. He argues that this unknowability is not a failure of mathematics but a fundamental feature of it, demonstrating that there are mathematical truths that are random and cannot be compressed into a finite number of axioms. Exploring Randomness, Springer Verlag, 2001. Exploring Randomness serves as a more technical and detailed exposition of Chaitin's work, compiling essays and papers that further elaborate on the theory and its applications. It offers a deeper look at the mathematical underpinnings of his ideas, including the formal proofs and technical details behind his concepts of algorithmic information and randomness. This book is a valuable resource for students and researchers looking to delve into the mathematical foundations of the field. Conversations with a Mathematician, Springer Verlag, 2002. This book is a collection of essays, talks, and interviews that provide a more personal and philosophical perspective on Chaitin's work. Conversations with a Mathematician explores his thoughts on the nature of mathematics, creativity, and the philosophical implications of his research. It presents a less formal, more conversational side of Chaitin, making his complex ideas more accessible by putting them in the context of his own intellectual journey and reflections. From Philosophy to Program Size, Tallinn Cybernetics Institute, 2003. This publication is a collection of lectures and papers that connects Chaitin's philosophical insights to the core technical concepts of algorithmic information theory. It specifically highlights how the abstract idea of philosophical randomness can be made concrete and measurable through the concept of program size, or Kolmogorov complexity. The book bridges the gap between the philosophical questions about the nature of truth and the practical, computable measures of information. Metamath. The Quest for Omega Pantheon Books 2005. Metamath is arguably Chaitin's most popular and accessible book. It is a compelling narrative that recounts his intellectual journey and the development of his ideas, with a particular focus on the number omega omega. He presents omega as a concrete, provably random number that encodes the answers to all possible halting problems. The book uses this concept to explain the profound implications of his work and its relationship to the limits of mathematics in a manner understandable to a general audience. Teoria algoritmica della complessità Giudicelli Editor 2006. This is the Italian version of one of Chaitin's works, focusing on algorithmic complexity theory. It presents the fundamental principles of the field, explaining how the complexity of an object can be measured by the size of the smallest computer program required to generate it. The book provides a thorough introduction to the concepts of algorithmic randomness and information, making it a key resource for Italian-speaking students and researchers in computer science and mathematics. Thinking about Gödel and Turing World Scientific 2007. Thinking about Gödel and Turing explores the intellectual lineage of Chaitin's work by placing it in the context of two of the most influential figures in modern logic and computer science. The book re-examines the works of Gödel and Turing and shows how Chaitin's algorithmic information theory provides a new perspective and deeper insights into their findings. It highlights how the concept of algorithmic randomness provides a powerful complement to their theorems on incompleteness and uncomputability. Mathematics, Complexity, and Philosophy Editorial Midas 2011. This book is a collection of essays that connects Chaitin's mathematical theories to broader philosophical questions. Mathematics, Complexity, and Philosophy explores the philosophical implications of algorithmic information theory, randomness, and the limits of knowledge. It presents Chaitin's perspective on the nature of mathematical truth, the role of creativity in discovery, and the relationship between mathematics and the physical world. The book serves as a bridge between the technical and philosophical aspects of his work. Gödel's Way, CRC Press 2012. In Gödel's Way, Chaitin re-examines Kurt Gödel's incompleteness theorems from the perspective of algorithmic information theory. He provides a unique and powerful interpretation of Gödel's work, showing how the incompleteness of formal systems is a direct consequence of the existence of random mathematical truths. The book argues that Gödel's result, while profound, can be seen as a specific instance of a more general phenomenon of randomness within mathematics, which his own work illuminates. Proving Darwin, Making Biology Mathematical Pantheon Books 2012. This book applies the principles of algorithmic information theory to the field of biology. Proving Darwin argues that evolution can be viewed as a form of computation, where new life forms are like programs being created by a search process through a vast space of possibilities. Chaitin proposes that randomness, a key component of his theory, is what drives evolution's creative power. He suggests that the complexity of life can be measured using his program size metric, thereby providing a mathematical framework for understanding biological systems. Philosophical Mathematics, Infinity, Incompleteness, Irreducibility Academy IA.edu 2024. As one of his more recent works, Philosophical Mathematics compiles new essays and reflections on the deep philosophical questions at the heart of his research. This online publication revisits his core ideas, focusing on the concepts of infinity, incompleteness, and irreducibility. It continues to argue that certain mathematical truths are fundamentally random and cannot be derived from a finite set of axioms, suggesting that the universe of mathematics is more complex and less reducible to pure logic than traditionally assumed. References. Review of Metamath. The Quest for Omega, by Gregory Chaitin. Siam News, Volume 39, Number 1, January-February 2006. G.J. Chaitin, Register Allocation and Spilling via Graph Coloring, U.S. Patent 4,571,678 1986 cited from Register Allocation on the Intel Registered Titanium Registered Architecture, p.155. Xenal, Hector Leibniz Medallion comes to life after 300 years. Anima Ex Machina, the blog of Hector Xenal, November 3, 2007. Pagalo, Hugo 2005, Introduzione alla filosofia digitale. De Leibniz a Chaitin Introduction to Digital Philosophy, From Leibniz to Chaitin in Italian, G. Giapicelli Editor, ISBN 978-88-348-5635-2, archived from the original on July 22, 2011, retrieved April 16, 2008.